Hi, in this video, we are diving into the basics of trigonometry. I will guide you step by step, so by the end, you will be able to solve trigonometry problems. First, what is trigonometry? Trigonometry is the branch of mathematics concerned with the relationships between angles and sides of triangles. In simple terms, we are saying that trigonometry helps us connect angles and side lengths, allowing us to measure, calculate, and understand shapes in mathematics and real-world application. Now, let's dive into trigonometric ratio. If we consider the right angle triangle that have side A, B, and C, we can be able to derive our trigonometric ratios. First of all, from our right angle triangle, we can say that this point here is known as the hypotenuse point. This is the point that is opposite the right angle. So we name here point C, known as the hypotenuse point. So it's called the hypotenuse point. Again, the side opposite to the angle theta is known as the opposite. So we call here side B, known as the opposite side. And side CB is known as the adjacent side. So we name here A, and we call here adjacent. Our basic trigonometric ratios are 6. So from our figure, or from our right angle triangle, we can deduce that sine theta is equal to opposite divided by hypotenuse. And from the figure, our opposite is side AC, assigned as small letter b, and the hypotenuse side is side AB, assigned as small letter c. So cos theta is defined as adjacent divided by hypotenuse. From our figure, our adjacent is side BC with respect to theta. So it is represented by letter A, and our hypotenuse side is side AC, that is given as letter C. Also, we have another ratio known as tangent. So it is called tan theta, and tan theta is defined as opposite divided by adjacent. With respect to theta, our opposite side is given as side AC, represented by letter B, and also our adjacent is given as side BC, represented by letter A. So we have defined sine theta, we have defined cosine, which is known as cos theta, we have defined our tangent, which we write as tan theta. But also we have our reciprocal ratios. And one of these ratios is known as cosec theta, and cosec theta is defined as the reciprocal of sine theta, which is equal to, we know from our ratios that sine is opposite divided by the hypotenuse. So the inverse of this, or the reciprocal of this, would be hypotenuse divided by opposite. Now from our right angle triangle, we know that our hypotenuse is given as side AB, known as C. Also, our opposite is given as side AB, represented by letter B. Another ratio we have here is known as secant, which is written as sec theta, and it is defined to be the inverse of cos theta. And we know that cos theta is given as adjacent divided by hypotenuse. So therefore the inverse of that is hypotenuse divided by adjacent. From our right angle triangle, we know that our hypotenuse side is side AB, which is represented as letter C, and also our side CB is known as the adjacent side, represented by letter A. So this will be C divided by A. The last ratio we have is known as the cotangent, represented as cot theta. This is known as the inverse of tan theta. And from our ratios, we know that tan theta is opposite divided by adjacent, and the inverse of that will be adjacent divided by opposite. So therefore, from our figure, adjacent is side CB, represented as A, and our opposite is side AC, represented as B. We have been able to derive the 6 basic trigonometric ratios using our right angled triangle. Now, let's take up an example to understand these 6 basic trigonometric ratios. Now, let's consider example 1. Example 1 says, from figure 1, which we have at the left hand side, show that sine theta divided by cos theta is equal to tan theta, and cos theta divided by sine theta is equal to cot theta. Let's derive these expressions. Solution. Number 1 says that we should show sine theta divided by cos theta is equal to tan theta. First of all, we know that from our figure that tan theta is equal to opposite divided by adjacent. Our opposite is side AC, represented by B, and our adjacent is side CB, represented by A. So we have to show that sine theta divided by cos theta is equal to B divided by A. Thus, sine theta is equal to opposite divided by hypotenuse, and cos theta is equal to adjacent divided by hypotenuse. From here, this expression becomes, we have that our hypotenuse, our opposite, and our adjacent has been defined in figure 1. So our opposite is side AC, which is represented by letter B. So we have sine theta is equal to B, and our hypotenuse is side AB, represented as letter C, divided by C, or divided by, and our cos theta is giving us adjacent of our hypotenuse, and our adjacent has been defined as side CB, represented as letter A, divided by our hypotenuse is side AB, which is letter C. Mathematically, this can be written as B divided by C, or divided by A divided by C. Now, applying the reciprocal of division, I can have that this becomes B divided by C times C divided by A. C, we cancel out C, and my expression becomes B divided by A. So therefore, tan theta is equal to B divided by A, which is sin theta divided by cos theta. Number one, I said we should show that cos theta divided by sin theta is equal to cot theta. And we know that cot theta is the reciprocal of tan theta. So we have here to be 1 divided by tan theta. And we have shown that tan theta is opposite divided by adjacent. Since it is a reciprocal at this point, it becomes adjacent divided by opposite. So therefore, our cot theta is giving us, our adjacent from our figure 1 is side CB, represented as A, and our opposite from our figure is side AC, represented as B. We can now show that cos theta divided by sin theta is equal to, our cos is giving us adjacent over hypotenuse. So we have adjacent divided by hypotenuse, and our sine is giving us opposite divided by hypotenuse. From our figure, our adjacent is side CB, which is delta A. Our hypotenuse is side AB, giving us delta C, all divided by our opposite is side AC, giving us delta B, and our hypotenuse again is side AB, giving us delta C. Mathematically, this can be expressed as A divided by C, all divided by B divided by C. Applying the reciprocal of division, our equation becomes A divided by C times C divided by B. C cancel out C, we are left with A divided by B. So therefore, cot theta is equal to A divided by B. It has been shown that sin theta divided by cos theta is equal to tan theta, and also cos theta divided by sin theta is equal to cot theta. Let's discuss about the Pythagoras Theorem. The theorem states that for a right angle triangle, the sum of the squares of the opposite and adjacent sides is equal to the square of the hypotenuse side. We are establishing that AB all squared is equal to AC all squared plus BC all squared. Thus, this can be represented as C squared equal to B squared plus A squared. And we can arrange this to become C squared equal to A squared plus B squared. This is known as our Pythagoras Theorem. Now, this theorem is useful when faced with a problem involving the sides of a right angle triangle. We can use the Pythagoras Theorem to find any side of a right angle triangle that is missing with the formula. And with this, it will be a useful formula as we proceed in the study of trigonometry. Now, let's take example 1 of our Pythagoras Theorem. In a right angle triangle, they said XYZ. Line XY is equal to 12 cm. Line XZ is equal to 15 cm. Find line YZ. To solve this problem, we have to represent it in a right angled triangle. So let's start with writing our solution. From the question given to us, our sides are S, Y, and z. We have that our xy is given as 12 cm and our xz is given as 15 cm. Now the question says find line YZ. We know that from our Pythagoras theorem that SZ all squared is equal to XY squared plus YZ all squared. So therefore our XZ is 15 cm equal to our XY is 12 cm plus our YZ is what we are looking for. 15 squared is giving us 225. 12 squared is 144 plus YZ, which is the part we are looking for. So from here we can make YZ our subject. So we have that YZ all squared is equal to 225 minus 144. So YZ all squared is equal to 81. And if we take the square root of both sides, YZ will be equal to root of 81. And this is equal to 9 cm. Example 2 says, a ladder 41 cm leans against a tree. The end on the ground is 9 cm from the tree. How high up the tree does the ladder reach? Just pause the video and feel free to solve it. From the example, we have to represent the statement with a right-angled triangle. Now, this is a right-angled triangle that we want to use to represent the statement given to us in example 2. I will call here A, I will call here B, and then I will call here C. Now the question says, a ladder 41 cm leans against a tree. The end on the ground is 9 cm from the tree. How high up the tree does the ladder reach? From the given example, line AB represents the tree. So we name it H as the height. Also, line AC represents the ladder that leans on the tree. And the value for the ladder is given as 41 cm. And then we are told that the end on the ground from the tree is 9 cm. And that is represented by side CB. So here is known as 9 cm. Now from our Pythagoras theorem, we can be able to obtain side AB. So our theorem states that AC, which is the hypotenuse side, is equal to AB all squared plus BC all squared. And our AC is 41 cm all squared equal to our AB is the height which we are looking for plus, and our BC is 9 cm. So therefore, if we simplify, 41 squared is equal to 1681. H squared plus 9 squared is equal to 81. Now, if we make H squared our subject, H squared will be equal to 1681 minus 81. H squared will be equal to 1600. So therefore, our H, if we take the root of both sides, will be equal to square root of 1600. So H will be equal to 40 cm. Example 3 has been given to us. It said, given that sin theta is equal to 3 divided by 5, Find the values of cos theta, tan theta, cosec theta, sec theta, and cot theta. The first thing we do here is to write down our solution. And we know that sine theta is equal to opposite divided by hypotenuse, which is equal to 3 here divided by 5. Now we will use our right angle triangle to obtain the value of our adjacent side. Now we have our right angle triangle, so we name the points or the vertices point A. Here I name point B, and here I will point C. And my angle is represented at point C. So here is angle theta. So from our sine ratio, our opposite side is side AB, which is equal to 3. And our hypotenuse side is side AC, which is equal to 5. Now, to obtain our side BC, we know that from our Pythagoras Theorem, we have that AC squared is equal to AB squared plus BC squared. Our AC is the hypotenuse side, which is equal to 5. Our AB is the opposite side with respect to theta, which is equal to 3. And our BC is the adjacent side, which we want to obtain. So therefore, we know that 5 squared is equal to 25. 3 squared is equal to 9 plus BC all squared. If I make my BC subject, I will have BC all squared equal to 25 minus 9. And this will be equal to 16. Now, if I take the root of both sides, I will have that BC is equal to root of 16. So BC will be equal to root of 4 squared. Now my square will cancel out the square root. So my line BC is equal to 4. So from here, we now obtain that our adjacent side is equal to 4. Now we can be able to find our cosine, tan, and other ratios. Since we have obtained the 3 sides of our right angle triangle, let's now obtain the ratios. So cos theta is equal to adjacent divided by hypotenuse. And from our right angle triangle, our adjacent is side BC, which is given as 4. And our hypotenuse is side AC, which is given as 5. Also, tan theta is equal to opposite divided by adjacent. From our right angle triangle, our opposite side is side AB, which is given as 3. Our adjacent side is side BC, which is given as 4. The next we have is our cosec. Our cosec theta is known as the inverse of sine theta, which is given as hypotenuse divided by opposite. From our right angle triangle, our hypotenuse is given as 5 and our opposite is equal to 3. Our cosec theta is equal to 1 divided by cos theta, which will be equal to hypotenuse divided by the adjacent. And we know that from our figure, the hypotenuse side is equal to 5 and the adjacent is equal to 4. And lastly, cot theta is equal to 1 divided by tan theta, which will be equal to adjacent divided by opposite. So from our figure, our adjacent is given as 4 and our opposite is given as 3. Now let's consider complementary angles. Complementary angles. These are two angles which add up to 90 degrees. If we consider the right angle triangle below, we have that PRQ is equal to 90 degrees, which is a right angle triangle. Also, we know that QPR is equal to theta, and also PQR is equal to alpha. Thus, for a right angle triangle, we have that theta plus alpha is equal to 90 degrees. So therefore, theta is equal to 90 minus alpha. Call this one equation 1. Or we have that alpha is equal to 90 degrees minus theta. Call here equation 2. From our figure, we can obtain that sine theta is equal to opposite divided by hypotenuse. And our opposite is given as P, and our hypotenuse is given as R. This is also equal to cos alpha. Now note that cos alpha is equal to adjacent over hypotenuse. So therefore, this is equal to P divided by R. But we know that our alpha is equal to 90 minus theta. So therefore, sine theta is equal to cos 90 minus theta. Equation 3. Also, cos theta is equal to adjacent divided by the hypotenuse, and our adjacent side is given as Q and our hypotenuse is given as R. This is also equal to sine alpha. Note that sine alpha is equal to opposite divided by hypotenuse. So with respect to alpha, our opposite is given as Q and our hypotenuse is given as R. So therefore, we can establish that alpha is equal to 90 minus theta. Thus, cos theta is equal to sine 90 minus alpha. Call here equation 4. From equation 3 and 4, sine theta is equal to cos 90 minus theta, and cos theta is equal to sine 90 minus theta. So we are given this example to solve on complementary angles. The first we have is that sine theta is equal to cos 35 degrees. But we have established that sine theta is equal to cos 90 minus theta. So if we replace sin theta with cos 90 minus theta, our equation becomes cos 90 minus theta is equal to cos 35. So from here, we can now equate our angles that 90 minus theta will be equal to 35. From here, we can make our theta subject. Our equation becomes 90 minus 35 will be equal to theta. Therefore, theta is equal to 55 degrees. B says sin theta is equal to cos 3 theta. Also, we have also established earlier that sin theta is equal to cos 90 minus theta. So if we replace our theta with cos 90 minus theta, our equation becomes cos 90 minus theta will be equal to cos 3 theta. Now we have that 90 minus theta will be equal to 3 theta. 90 will be equal to 3 theta plus theta if we move theta to the right hand side. So we have that 90 is equal to 4 theta. Therefore, theta is equal to 90 divided by 4, which is equal to 22.5 degrees. Now, C is giving us cos 2 theta equal to sin 3 theta. Also, we have established earlier that cos theta is equal to sin 90 minus theta. So therefore, cos 2 theta will be equal to sin 90 minus 2 theta. Now we will replace our cos 2 theta with sin 90 minus 2 theta. Our equation becomes sin 90 minus 2 theta will be equal to sin 3 theta. So therefore, we have that 90 minus 2 theta will be equal to 3 theta. From here, we can establish that 90 will be equal to 3 theta plus 2 theta. So we have it that 90 will be equal to 5 theta. So therefore, theta is equal to 90 divided by 5, which is equal to 18 degrees. That is our value of theta. So this says that cos s is equal to sin x plus 22. Also, we know that we can substitute cos s to be equal to sin 90 minus x. So therefore, this can be written as sin 90 minus x will be equal to sin x plus 22. Now our equation becomes 90 minus x is equal to x plus 22. From here, we can collect like terms. We have 90 minus 22 is equal to x plus s. So therefore, we have that this becomes 68 equal to 2x. So s is giving us 68 divided by 2, which is equal to 34 degrees. So the angle s is 34 degrees. Now I believe that you have found value in this video. Please subscribe to the channel and like the video. If you have any question, drop your question in the comment section and I will reply you. Thank you so much, and I will see you in the next video.